Okay, happy Monday, everybody. Hope you're all doing good so far. Okay, we are here at week 2. So we're gonna continue some stuff from last week. If folks want to see the future of this class, once again, there is a link here, the weekly schedule and topics. It's gonna show the some stuff up ahead. There's a upcoming project. I haven't published this yet, but it should be coming out in a couple days. This next project is going to consist of doing some math and taking input. Well, in the other order. Well, you'll be taking input and then doing some math with it. So that's going to be what the project's going to do. All right. Let's see. Cool. The goal of today is to kind of recap a bit on input and output. We'll do this in like probably half an hour. But I wanted to cover some fundamental data types. So today will really mainly consist of these two topics here, variables and arithmetic. That's the goal of today. I highly recommend going through this supplementary material. These numbers are referencing these over here. So if you go to the syllabus, I'm referencing this University of Helsinki. I'm heavily recommending on folks to read through this. It's gonna cover quite some gaps that I might not hit in the course. But yeah, 1.4, 1.5, that's over here. So this is part 1, and then 1.4, 1.5. That's pretty much these two sections over here. So yeah, please take a look through those. It would be a good use of lab time. All right. Cool. A quick couple announcements before we start. There is the lab that's due on Wednesday. Typically every Wednesday there's going to be a lab due. And then assignment 0 is due this Friday. This is the banner assignment. Y'all should have enough to get that done from last week's lecture. But yeah, assignment 0 is this one right here. This is writing a program that outputs multiple lines. And I did suggest folks to use a generator for this. You can Google up ASCII art generator. And then I like this person's over here, this Pator person. So you could use this person's tools. Just make sure you cite the source. This way you're giving credit to whoever made this tool. Please cite your source. Okay. Finally, there's a couple deadlines here. These are just colored deadlines. So Saturday, this is the last day to drop or add another class. And then Sunday, this is the last day to get a full refund on classes. All right. Let's get started with today's material. So once again, today we're just going to cover variables and arithmetic. That's really it. It's probably going to be overly detailed. I hope I'm not too detailed for folks, but this is one of the building blocks for this whole class, variables and arithmetic. So I'm going to be quite detailed. It might seem like it's going slow. It might seem like I'm being way too descriptive, but it's kind of necessary, especially if you're like a first-time programmer. I have to go over these small little details. Okay, and I will cover input and output again in more detail. But yeah, let's go over variables real quick. Last week we got a sneak peek into what variables are. So let me pull up my VS Code. Last week we left off on this example. We left here. Let me full screen this. We left off on this example here where it takes input and spits it back out. Let me go ahead and test it. So once again, on the terminal down here, I need to navigate to the correct directory. So I'm gonna go into examples, and then let me do an ls to make sure it's there, and input.java. Cool. Let me compile and run it. Okay, cool. So I compiled and ran it. The program is not done, by the way. It's actually still executing, or not executing. It's waiting for input. So we did this first statement in the program. It outputs write a message down here, but then the program is waiting for input. Once again, this is a read line input. It's waiting for the user to type something. So the second I type something, I'll just type in my whole name, Andrew space tac. It doesn't matter. This is a line of text. The second I press enter, this method will terminate and return a value. We'll talk about what return means, but it really means that this thing I highlighted collapses to a string. It collapses to a text. And then that text is stored in a variable called user input. So then this last statement is really just printing it out. So let me press enter. And yeah, so I pressed enter and then it just echoed it back out. So you can get fancier with this if you want. You can add more stuff to the print statement to further visualize this. Like I'm just gonna do some concatenation. So let me just, this is called string concatenation, which means to glue strings together. These two, I'm just gonna say in this string, I'm gonna say you typed. Okay, cool. Let me recompile and rerun this. So recompile, write a message, hello world, enter, and yeah, it says you typed hello world. Cool, yeah, so this is where we left off at from last week. The sneak peek we got was this line right here on line 5. We used a variable. So let's dive deeper into what variables are. For today, we're just going to work with numbers. And then on Wednesday, we'll work with more strings. Okay, let me quit this example over here. Okay. Cool, yeah, variables is kind of like something is very similar to the terminology in math. In computer science, you can think of a variable as a location in memory that can possibly change. A lot of programs require you to store data. So you can store this data in memory. By the way, do folks know the difference between memory and storage? I'm just going to pull up a picture real quick. So memory versus storage. Let me see if I can pull up a picture. If folks have ever opened up your computer, like your tower or maybe even your laptop, there's going to be some components here. There's something called the RAM sticks. RAM stands for random access memory. This is like short-term memory. Whenever you reboot your computer, this left side is volatile, meaning it's going to reset. So yeah, memory is kind of like short-term for when the computer's on, and then storage. This is like your long-term storage. When you turn your computer off, the data will stay. So this is like a hard drive. Nowadays, I think people are using solid-state drives, but it's more or less the same concept. So just to formalize it real quick again, these files here, you see this hello.java. This is a file. Input.java is also a file. These are stored in the storage. For me, I have a solid-state drive. I have a solid-state drive, 4 terabytes. So that's where this whole file is stored. But this line of code on number 5, this is storing data in a memory, the volatile storage. So user input right here is stored in the memory over here, the short term. So yeah, just a quick difference between those two in case folks aren't aware. Okay, so yeah, we can store stuff in memory. Let's formalize some terminology real quick. So there's something called a declaration. This is a line of code that tells the computer we need space. we need space and memory to store data. And then there's something called an initialization. This is when we assign a variable. Assign means to set the right to the left. So once again, the flow of data goes from right to left. A 9 goes to A. You can do this in a single line, by the way. For example, in the input over here, in the input.java, those two are done in a single line. You could do that in 2 lines to split it up if you want. So this single line is the same as declaring a variable. So this is declaring a variable. Once again, this means, hey computer, I need space for a string. And then you can go ahead and initialize it if you want. So you could, so user input is equal to io.readLine. And this is initializing the variable. So yeah, these 2 lines is the same as this. This first one is just a shorthanded one. 2 in 1. Okay. We'll talk about what an int is later. This is an integer, but we'll make more detail on it. All right. There's some naming conventions, by the way. These is defined as how you can name the variables. So if you take a look through the reading, let me see. There's going to be a little more detail on this. The reading here is 1.4, and then let me look for naming. So if you search for the naming variables, they're going to go into a little more detail on this. They'll talk about illegal names and legal names, and some conventions as well. In conventions, I'm talking about like how people name their variables. One example is called camel case. Camel case is kind of like a metaphor for an uppercase in the middle. We would start with the undercase, and then on the next syllable, it would be uppercase. So this means if I were to use camel case as a convention, then I would have to rename this variable here to user and then uppercase input. So this is camel case. Unfortunately, if I were to rerun this, I'm gonna get something called like I think it's called a compiler error or a syntax error. So let me try to compile this real quick. The reason why I'm gonna get this syntax error, so this syntax error here is pointing at line 8 right here. It's saying user input, the compiler cannot find this symbol here. This just means that this doesn't exist, and it does make sense. It doesn't exist. We never declared a variable named user underscore input. We did use this camel case, so we have to rename these future variables along with this one over here. So let me replace this one, and then let me go ahead and retry it. So let me press up on the keyboard. Once again, up on the keyboard goes through your history. And then, yeah, there we go. It compiles, and now we're running. Cool, so that's just what camel case means. I believe most people in Java use camel case. Let me check. If you're ever gonna work in the industry, the company will enforce some rules. For example, the Google, if you work at like some sort of, let's see, what's it called? FANG. Have people heard of FANG? It's like Facebook, Apple, Adobe, Netflix, Google. If you ever try working at any of those tech companies, they're gonna enforce some sort of style. So for example, there's something called a Google style guide. A lot of companies go by this. So let me just check the Java style guide. Okay, so Java style guide. I'm just gonna see how Google enforces this. Okay, let me just look for the naming conventions over here. Okay, naming conventions. Okay, let me see what they go by. Variable names. Okay. It looks like in the Google style guide they prefer lower camel case. So that's the one that I'm probably going to use in the future here. This is lower camel case. Okay. Cool. There's underscore camel case as well. This is some companies prefer this. I prefer the underscore camel case. In my opinion, it's easier to read. But yeah, once again, it doesn't matter too much until you are working in a place that enforces clean code. Okay, any questions about this so far? We'll get into a tiny bit more detail. Okay, cool. Let's move on then. All right, let's cover something called primitive data types. A primitive data type is like a native type that belongs in Java. For example, a string is a type. This is a type that we'll jump into more detail in the future. But for today, we're just going to be talking about numeric data types. In particular, I'm just going to mention these two over here. That these are probably the more important ones we'll see. Something called an integer. So we'll talk about this today. And then finally, something called a double. So yeah, just two of them today. An integer is like a type that represents numbers, but not the decimals. And then doubles can represent decimals. People might be wondering why we need two different types. We'll talk about that in just a bit. But let's go ahead and apply this real quick, and it should make sense in just a second. So I'm gonna go ahead and make a brand new example in the VS Code. If folks want to follow along, go right ahead. I will be uploading this to the canvas. If folks want to download this, you can just go to the canvas and download it right here. So let me just pull it up. So you can go into canvas, go to the files, and then there's an examples folder here. I'll be uploading all of the demonstrations here. Okay. So let's go ahead and make a new folder. A new file, I mean. Okay, so I'm gonna put in the examples directory. New file over here. I'm just gonna call this arithmetic.java. I'm calling it arithmetic because this is going to evolve into some math. We're gonna showcase some operations like addition, subtraction, and all of those things. Okay, so arithmetic.java. I'm gonna set up the boilerplate real quick. Boilerplate means we'll learn this setup stuff later. Like, oh, what is void? What does main mean? We'll talk about that later. But for now, let's just focus on the stuff between these two curly braces, which represent the body of this method. Okay, let's go ahead and declare our first variable. For now, I'm going to keep it simple and use something called integers. Integers are types that can represent numbers. In this case, there's a certain range. We'll talk about why this range exists. But you can imagine an integer as a type, a memory location that can store like 0, 1, 2, 3, 4, 5, and the negatives as well. So let me go ahead and declare a couple variables here. I want to declare like an integer. I'll call it A. And then I'll declare another one too, int B. So I declared two variables, meaning the computer allocated memory. The computer allocated memory for two different variables, two different integers. So they are uninitialized. I'm gonna go ahead and assign them a value. This is called hard coding. So I'm hard coding A to represent the number. Let me think of a number. Let's go 12. It doesn't matter too much. This is just for showcasing things. B, I'm going to initialize this to 5 for now. So I did mention that this is called hard coding. Hard coding Hard coding means the data lives in the source code, meaning that whenever we run the program, these variables are always going to represent the same exact number. But in about half an hour, we're going to not hard code this. Instead of the data living in the source code, we're going to evolve this into input, meaning we're going to insert some functionality where the user would have to type in the numbers for us. This would be a little more general. Okay, so I just declared and initialized two different variables. It's a good programming practice to compile often to make sure it's working. So let me just go ahead and compile this real quick. So I did save it, by the way. So make sure you save it, and then let me go ahead and run it. So compile and run. So Java arithmetic.java, and then enter. Hopefully there's no compiler errors. Cool. There's no compiler errors, and it did run. There's no output though, which makes sense because we never did any print statements. Okay, cool. So let's do a bit of math real quick, and then we'll do some input in just a bit. So for the math, I wanted to cover all of these operations here. These operations work with numbers. Addition, subtraction, division is going to work a little differently with integers. We'll talk about this in just a second. Multiplication works. And then there's something called the modulus, this last one. Modulus is an operation that takes the remainder from integer division. This is useful for certain things. So let's go ahead and apply all of these math operations so people are aware of them. Let's do the math one first. So first of all, I'm just going to wrap them in a print statement actually. So I'm just going to do a print statement for every operation, like io.println. I'm just going to do a bunch of print statements that represent like, what is a plus b? Or first, I guess I'll print these numbers first, just so people see it. So I'll say, a is currently, so a is equal to, I want to put a here. And then I'll put comma b is equal to b. Okay, so all this does is it just outputs the values of these hard-coded variables. Let me go ahead and test it. So Java, and yeah, so the print statement is saying, hey, a is equal to 12, b is equal to 5. All right, people cool with this so far? We did some string concatenation here, so inside of these parentheses, this is one whole string being put together. Okay, let me do another print statement for the addition. I'll zoom out a tiny bit. I'm just going to do a io.println, and then I'll say, what is a plus b? So a plus b is equal to equal to some result. Okay, I'm going to put the result here as well, one way you can do it is you can calculate it before. You can pre-calculate the result and then put it in here. So if you wanted to pre-calculate the result, you could say something like, you could declare another variable. You don't have to do this. There's many ways you could do it. You could say int sum is equal to a plus b. So this line right here is declaring a variable called sum, and then it's setting it to the right side. So the right side is a plus b, meaning that we can insert this sum, this pre-calculated result here. Okay, so yeah, this is just one way. Let me save it real quick. So save and then run it, compile and run, and there we go. Let me verify the output. Yeah, a plus b is 17. That looks right. All right, people cool with this so far? Just a bit of things on variables. All right. I did want to mention a quick caveat that can happen. Something called order of operations. It is possible to just calculate the sum inside of the print statement instead of pre-calculating it. So you know, instead of wasting memory for this, you could put it in here. You could say a plus b. You see what I mean? But however, the order of operations is going to treat this a little differently. If I were to compile and run this, it's going to say a plus b is equal to 125. That's not it. It should be 17. So there's something funky going on here. People might realize that this is doing something called string concatenation, where it's gluing 12 and 5 together. It's not really treating 12 and 5 as integers. It's treating them as strings and kind of gluing them together. The reason why is due to the order of operations in this second print statement. The order of operations perform this addition here. So this part that I highlighted, it's performing a string concatenation. This is the first operation to happen. So it's saying a plus b is equal to plus this. So then so a is 12. So it's pretty much doing like 12 right here. That's what a is, and then 12 gets concatenated to here, and then finally a b gets concatenated. But b is 5. So yeah, do people see what's happening here? That this is accidental string concatenation, and this happens because of order of operations, incorrect order of operations. One way you can mitigate this is just by putting parentheses around here. You know how in order of operations there's something called PEMDAS. PEMDAS is a algebraic concept. So let me just pull it up real quick. PEMDAS is an order of operations concept. P stands for parentheses. This means parentheses are evaluated first. And then there's some other operations too, like exponents, multiplication, division, addition, subtraction. These take the less precedence. So yeah, that's kind of what order of operations is. When we put parentheses around the sum here, a plus b is evaluated first. And in this case, since a and b are both integers, this is going to be evaluated as integer addition. So a plus b evaluates to 17. And then finally, the order of operations would take this next. And it's going to be a string concatenation because the left side is a string. So let me go ahead and save this. And yeah, we finally get the correct result here. So this is what happens when we add these parentheses here. All right, people cool with this so far? Order of operations, adding stuff. Okay, let's quickly do the other operations. I'm gonna do the subtraction. So a minus b is equal to the result of a minus b, and semicolon. Let me test this again. We want to compile frequently, catch the errors earlier on. Okay, cool. I just compiled and it tested. A minus b, 7. That sounds about right. 12 minus 5 is 7. All right. Let's do a few more. Let's do multiplication. So a times b, and then I'm going to concatenate it to the results of a times b. Okay, let me test this. So save, recompile, and yeah, 12 times 5 is 60. That looks right. Okay, let's do division. So a divided by b is equal to the result of the integer division. Okay, cool. So let's save this, save and recompile. All right. So yeah, check this out right here. A divided by b gives us 2. Isn't that a little weird? 12 divided by 5 should be 2 point something. Let me verify that. See, 12 divided by 5 should give us 2.4, but it's giving us 2 for some reason. This is called integer division. Integer division can be a pitfall. It can be useful as well. In this case, maybe you could consider it a pitfall because we lost precision. So yeah, integer division ignores decimals. So what's happening here is it's kind of called it's called truncation. Let me write this down. So integer division, this truncates the decimals. Truncate means to cut off. It does not mean to round. So there's no rounding at all. It's just ignoring the decimal. So a divided by b does evaluate to 2.4, but with integer division, it truncates the decimals. The reason why it does this is in the representation of integers, there's no way to store these decimals. We'll talk about why in just a bit. We'll talk about binary soon, so it should kind of make sense why we can't do that. But yeah, people cool with this so far? Integer division. Okay. This will be useful for a lot of things. In a couple of weeks, we'll have an assignment where you'll see how integer division can be useful. Same with modulus. Modulus is taking the remainder. So let me just do that over here. io.println a mod b. So this is a percentage sign. This is taking the remainder of division, and then I'm going to concatenate the result of a mod b. So this is called modulus, which gets the remainder from division, from integer division, actually. Okay, so let me go and save this and recompile and run. Okay, cool. So yeah, let's look at this last one. So a mod b gives us 2. This is a coincidence with the division. A mod b is 2 because it's 2 remainder 2. You see what I mean? If you were to do like classic long division with this, 5 fits into 12 2 times, and then there's 2 left over. So that's kind of what the modulus is giving us. You can go ahead and change these hard-coded numbers just to verify. Like if I did 14, I'm going to change a to 14. This should give us a different remainder. So let me test this. Let me save and then recompile. There we go. We get a different one. A is now 14. So when we do the division integer, it's 2 remainder 4. Does that make sense? Okay. People might be wondering about these last 2 operations. What's the point of integer division? What's the point of modulus? There's tons of uses for this. I'm thinking a future assignment will consist of validating cards. And there's this algorithm. It's called Loon's algorithm. This is a way of checking to see if a credit card is typed in correctly, or if there's any small typos here. So yeah, Loon algorithm. This is a verification formula. It basically allows you to type things in. Like, let me pull up someone's code here. Someone's tool, I mean. Let me just Google it. Loon algorithm tool. So this is a tool that lets you type in certain numbers and verify if they're a valid thing. For example, is this a valid number? Let me just type in some random numbers here. Okay, I just typed in some random numbers. Is this a valid number? Let's see. So I'll verify it. And no, it's not. It's not valid. Oh, why is it not valid? Well, this number goes through a series of operations. It goes through a bunch of integer divisions, and it goes through some modulus calculations to verify whether or not it's correct. If I were to do a valid credit card, or it's not with credit cards, it works with library cards as well, and I think it works with account numbers too. But here, let me type in a valid card number, and you know, I'm gonna use an expired card. I think I have an expired card somewhere. Let me see. Give me 1 second, folks. I'm gonna search for an expired card. Let me see. Where's my wallet at? Okay, give me 1 second, folks. Let's see. That is not expired. 1 second. Let me see. Okay, you know what? I'm gonna use a gift card that has no money on it. Okay, so I'm gonna type in some numbers here and see if it's valid. 6033 2 and then 0741. All right, I just typed in some numbers. The spacing doesn't matter too much here. Okay, is this valid? Let's see. So I'll verify it. Oh, I think I have a typo here. 6166 60 0882 0741. Oh, okay. It looks like this gift card doesn't adhere to Loon's algorithm, which is a little weird. So yeah, a lot of credit card companies adhere to this algorithm, meaning that when they generate the number, it's supposed to be verified by some algorithm. Here, let me look for a different card real quick. I'm using a. That's weird. I thought most cards. Okay, hold up. Let me look for another one. Give me 1 second, folks. Okay, try a different one. Oh, okay, cool. I just found an expired one. Okay, this one should work. So 4815. This is, if folks are curious what I'm looking at an expired Bank of America card. 1255 8095. Okay, let me just get rid of these spaces. Okay, and let me verify. Okay, cool. So I just typed in a number, and for some reason this is a valid number. So yeah, this number is kind of being treated like an integer. It's going through an algorithm that calculates some things, and it just happens that the math comes out to be valid. If I were to make a typo here, like let's say I made a small typo in this number, I'm just gonna change the 0 to a 1. So I'm gonna change the 0 to 1, and now if I verify, this is no longer a valid card. So yeah, Loon algorithm is kind of like a first step. It verifies if there's a typo, and then if it's a valid card, it's going to send the card up to the bank, and then it'll get charged or whatever. So yeah, this is just one step in verifying. How this works is kind of through a series of divisions and modulus. These two are being applied: integer division and modulus. If you want to take more detail into this, you could Google up Loon's algorithm and check out this wiki. I will most likely deploy an assignment that uses this algorithm later. So yeah, feel free to take a look at it. It's some pretty cool stuff. Okay, any questions so far about some math? Okay, cool. All we did so far was talk about integers and the arithmetics behind it. All right, cool. Yeah, feel free to let me know if there's any questions. Okay, I'd be happy to answer them. Okay, let me clean this code up a bit. Okay, let me save this. Cool. Okay. I guess we could talk about converting things real quick. Sometimes people don't want integer division. There's many ways you can mitigate this. One way is just by using doubles instead. So in Java, there's an integer, that's what we're using. But there's also floats and doubles as well. These are pretty much the same data type, but doubles are more precise. So one of the easier ways is you can just use doubles instead. So instead of an integer, I could use double, and then use double here, which is going to represent the numbers with decimals. So there are like invisible decimals here. You just don't see them. There's like a 14.0 here. There's like a 5.0 here. You don't have to put these in, but that's kind of how they're being represented right now. So since they're being represented as doubles, this should no longer be treated as integer division. And let's test it. I'm going to comment out this modulus. So with integer division, double division, this is going to give us whoops. There it is. People see what's happening here. We're now treating these as doubles. So there's like invisible point zeros at each of these. But then when we get to the integer division, we finally don't truncate the decimal. So yeah, this is just one way you can do it. I don't think modulus will work. Modulus, I believe, is reserved for integer. So this might not work. Let me comment it out and then save, and then, whoops. Let me save this. Save, recompile. Okay, it looks like we do get the modulus as well. Nice. That's probably because the modulus is treating this as integers, but then putting it back to double. Okay. I'm going to change these back to integers though. Okay, and here's our back to integer division. A divided by b is 2. So yeah, we just saw one way of treating it like double division. Another way is doing something called casting. Casting is kind of like a conversion. So we could just convert one of these to a double, and it'll not truncate the decimal. One way you can cast is by putting these parentheses and then putting double here. How Java evaluates this is it sees double A, so it's gonna force the integer to be a double. So yeah, this is called, if you're curious, this is called casting. So I'm casting an integer to a double. I'm forcing an integer to be a double so I can maintain the decimals. Okay, let me save this. Compile, and there we go. We get 2.8 because it's treated like a decimal. Okay, hopefully people are cool with this so far. let me bring it back to normal. Okay, any questions about this so far? Okay, cool. Just a bit of math. All right, let's move on then. All right. So we covered something called an integer. This is good for like whole numbers, negatives as well. And we covered doubles. Doubles are the same as floats, by the way. It's just that doubles have more precision. The reason they have more precision is because they use more memory. Doubles use double the amount of memory as a float. Nowadays, most people are using doubles because with modern hardware, we have 64-bit systems, and 8 bytes means 64 bits because there's 8 bits per byte. All right. Folks might be wondering, why are there so many types? So maybe you have come from a Python programming language. Python, you don't have to specify the type because Python is not a compiled program language. But in Java, this is one of those languages that's called statically typed. Statically typed means the compiler must know what type of variable is being used. This is for safety. For example, if I were to here, let me comment all this stuff out. It's kind of like for safety. If I were to say a is equal to 14 here, so this is valid in Python. Just saying a is equal to 14. But this is not valid in Java. First of all, if I compile it, it's going to say error on line 2. Cannot find symbol. It's Java. The compiler needs to know how to store the data. 14 could be stored as a string as a text, or it could be stored as a number, like an integer or a double. The reason why we might want to use different types is because operations are different on different types. Folks saw that integer addition is different from string addition. You know what I mean? When you're adding strings, it glues them together. But when you're adding numbers, it does the actual math arithmetic. So it's kind of for safety here. For example, if I were to say string a is equal to 14, this is just a small thing. This is not going to compile for safety reasons. One is both sides don't match. So the right side here, this is being evaluated first. It's being evaluated as an integer, is an integer literal. So let me just comment out real quick. So 14 is an integer literal. A literal is like a value that lives in your source code. So it's saying, hey, I cannot store an integer in a string. If you wanted to mitigate this, you could treat 14 as a string. And one way you could do this is by wrapping it with double quotes. This is going to treat it like a string here. And yeah, it does compile. But if I uncommented the rest of this, the program would probably behave a little weird because now we're treating a as a string. Let me revert all of this. Control Z, Control Z. Okay, I'm just reverting it back to normal. So yeah, the one reason is for safety. This is to protect us from operations that shouldn't happen. Okay. Let's see. Variable types will vary based off their memory usage as well. You saw this in the table earlier. Over here in this table. So some things have different memory usages. Like integer, it just happens, it uses 4 bytes. 4 bytes is equivalent to 32 bits. And with 32 bits, we can store a certain range of this. People might be wondering, oh, what's up with this range here? We'll talk about this when we mention binary. But yeah, certain types use different amounts of memory. I didn't include strings in this table because strings is not numeric. And then also, strings are kind of a fancy thing in Java. Strings take up a lot more memory than integers. So sometimes, so yeah, it's pretty necessary to define how to use these. This way you can optimize your code a little more. And also the variable types have different operations too. You saw this in the arithmetic example. If we were to with the integer division, that this is an operation, but the operation varies based off the type. If we're using integers, it'll truncate the decimals. If we're using doubles, the decimals won't be truncated. So yeah, variable types have different operations. Okay, people cool with this so far? Okay, cool. There's a couple pitfalls that you might run into. We saw integer division here. This can be a pitfall depending on your task. Yeah, integer division means we're treating both sides as literals. In this case, 12 divided by 5 evaluates with 2. But if you were to treat them as like doubles, like this, so in this case, the numerator is being treated like a double literal, and this is going to evaluate to 2 point something, 2.4, I believe. Okay, so yeah, that can be a pitfall. We saw another pitfall was order of operations. So sometimes you're mixing types. So I'm mixing strings with integers, and the order of operations here go from left to right. So the string 1 plus the integer 2 evaluates to 1, 2. I know that seems kind of weird, but it's the reason why is because one of the sides is a string. So the Java compiler will treat this first as string concatenation, and then same with this 3. So it's going to be 1, 2 plus 3, which gives you 1, 2, 123. Okay, so you could print that on your own time. But yeah, this is not the same as this order of operations here. If I were to wrap the 2 plus 3 in parentheses, this right side will be evaluated first. 2 plus 3, these are both integers, so it'll treat this as 5. And then 1 plus 5 gives you 1, 5. All right, people cool with that? This is different from the top. These can be pitfalls. There's also another one, which is going to lead us to something called binary. Integer overflow is a integer overflow is kind of like a concept where you run out of memory, so the memory resets back to a certain side. For example, if I were to represent an integer being a really big number, so let's talk about integer overflow real quick. For now, I'm just going to comment out all of these. Let me just comment out all of these. Once again, you can comment by highlighting it and then pressing Control/. So Control/, that's a VS Code shortcut. I'm just going to do a single line here, keep things a little simple. Let's say I were to store an integer. I'll just call it X for now, or I'll call it big number. I'll call it big number with a camel case. And then for some reason, I'm just going to set it equal to a large number. Let me see real quick. I'm gonna set this equal to 2,147,483,000 and then 646. Cool. So this is a big number. This is a integer literal. If you wanted to, I think you can use apostrophes for readability, like as a comma. So this is just for readability. Oh no, I think in Java it uses underscores. My bad. So yeah, you could use underscores for readability. It doesn't matter too much. But here, this is going to compile and not output anything. But let me output this real quick. Let me go io.print line, and let's just print out big num. Okay, so this is going to print out what we expected, 2 billion something something. So that's exactly what we have it. But let me go ahead and add some numbers to this. So I'm going to change big num. All right, so big num is a variable, meaning that the value can possibly change. So if I make another statement here and say big num is equal to big num plus 1. Okay, I do want to reiterate something. The right side is evaluated first. Yeah, this is very important for most programming languages. The right side gets evaluated first and then gets stored to the left side. So this is called accumulation. So all we're doing is adding 1 to the variable and then storing it back to the original location. So we're accumulating, and then let me go ahead and save this. So save, Control S, and then run. And we're getting 2 billion, something, something, and then 7. Okay, cool. This looks about right. But let's go ahead and add one more. So I'm going to accumulate one more number. Okay, there we go. We're accumulating another one. And let's see. Okay, so let me test this. So Java, arithmetic.java, enter. Okay, check this out. It looks right, but it's not because of this negative here. Well, why did it become negative all of a sudden? Kind of weird, right? Let me add another one. Okay, I'm accumulating another one. So this is pretty much saying big num plus 3. That's all it's doing. We're accumulating 3. And then test it. And check it out. We get this number here. Negative 2 billion something all the way to 647. But basically this is not right. You can keep adding it and you're still gonna get the incorrect result. And yeah, we still get a negative number. You know, in math, this should be 2 billion 650 something. But yeah, why did this happen? So this is kind of an important concept called integer overflow. Let me pull this up. All right, integer overflow exists in a lot of programming languages. Basically, integers have a certain amount of bits. In Java, integers are represented with 4 bytes. Okay, 4 bytes translates to 32 bits because there's 8 bits per byte. And with 32 bits, there's only a certain amount of numbers we can store in that memory. Okay, and this brings us to something called binary counting. So once you understand binary counting, this should make sense why it overflowed. So in the computer architecture, there's something called transistors. Transistors, you can think of them as like a light bulb that's either on or off. And these transistors store data. So deep in your computer, data is being stored as transistors that are either on or off. For now, you can think of these as numbers. So let me pull up this mechanical binary counter on YouTube. This is a really good illustration on binary counting. Okay, so someone here made a binary counter, a mechanical one. You can imagine this as an integer that has 6 bits. 6 bits, I mean, like, 6 light bulbs or 6 transistors. So with 6 bits, what is the largest number we can store? Well, let me play this real quick. So in binary, 0 is represented as 0. 0, I'm talking about like decimals. So as humans, we count with our fingers, meaning that we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we run out of fingers, so then we have to carry another one. But with binary has 2 fingers on each bit. So when we go 1 is represented as 1 here, but then binary runs out of bits. So 2 is represented as 1, 0. 3 is represented as 1, 1. And then 4 is represented as 1, 0, 0, and so on. So this right here is showing binary accumulation. We're adding 1 to the memory location, and it's carrying over every time. So yeah, once again, what is the biggest number we can store with 6 bits. Let's see. I'm gonna fast forward a bunch. Actually, no, I'm just gonna leave it as here. It's a pretty short video. Okay, keep going. Almost there, folks. Okay, let me fast forward it. Okay, check this out. So I fast forwarded a bit. It looks like the biggest number we can store with 6 bits is 63. There is some math behind this if you're curious. 63 is 2 to the 6th power minus 1. But then when we accumulate another number, let's see what happens. So we accumulate another number and it overflows. Overflows means it resets it back to the left side. So that's kind of what's happening in this code right here. We started an integer at a very large number, and the memory is running out of bits to represent it. So when we keep adding it, we're going to overflow at some point, and it happens to overflow to the negatives. You can think of it as overflowing to 0, but since integers have a different number line, we overflow to the negatives over here. All right, people cool with that so far? Hope that kind of makes sense what binary is. This is worth talking about. I'm not going to talk about binary too much, but if you're going further into computer science, it's worth understanding binary a bit. So feel free to take a look at this. There's a whole class dedicated to this, by the way. If you go to CS-12, computer architecture and organization, they're going to talk about binary quite a bit. Okay. Cool. Any questions so far? Okay, cool. Let's move on then. Okay, hold up. Let's take a 5-minute break real quick. We're about halfway through the lecture. Let's take a quick 5-minute break, and then we'll move on to a class exercise. I'm gonna grab some water. Let me pause the recording here real quick. Pause the recording. All right, we're back from intermission. Let's move on to a class exercise. Let's see. There's something I skipped over, something called constants. You know what? Let's just talk about this during the class exercise. But quickly, a constant is kind of like a variable, but it should never change. Sometimes you'll have some numbers that aren't really supposed to change, like pi. Pi, you can treat this like a variable, but it's better to treat this as a number that shouldn't change, because you don't want pi to change. You know what I mean? Like let's say you were programming a something for the satellite to make an orbit. If an attacker were to, or if a programmer like a coworker were to try to change pi, that would be considered insecure, and it would be necessary to make some variables read only, meaning the variable should never change. So we'll talk about this in this next class exercise. It should make a little more sense. Okay, typically I have class exercises. I did adapt this class from an in-person one. This is the first time I'm teaching this class hybrid. Most folks are watching this as a YouTube video. So I'm going to just do this class exercise a little differently. This would be a good practice for like exams, or these exercises also hint towards our next programming assignments. And I would suggest for these exercises to pause the video and try it out yourself. This way you'll have a bit of creative exploration and get exposed to the problem solving process a bit. Okay, so for this class exercise, there's going to consist of a problem and some expected output. So the problem here is going to be dealing with an area of a circle. For folks who have taken some sort of algebra class, you might remember the area of a circle is represented by this formula here, pi times the radius squared. So let's say we were to write a program that prompts the user for a number. This means that if the user were to type in some number, and maybe the program would use that number to calculate something. So for example here, the expected output, this is like an answer key, but it doesn't show the answer, it just shows the expected results. For example here, you should expect your program to output type a radius. And then this 5 is in red because it represents the input. So the user would type in 5, they would press enter, and maybe the program would do something. In this case, the program uses that number to calculate. The area is 78.5, which came from this formula here. 5 squared times pi turns out to be 78.54. So let's see another test case. Another test case is you run the program again, and then it says, oh, type a radius. So this time we type 2.4, and the area should be should be different. All right, so hopefully people kind of see what the class exercise are. I would give this a shot, but at this point, it might be a little difficult because we barely covered input, especially taking input into numbers. So far, all we talked about was input with with strings. But let's do this real quick. I mean, not real quick. I'm gonna go ahead and create another file here to do this. Let me put here. Okay, let me make another file. Let me quit this. I'll store in the examples again. For this one, I'm just gonna call it area of circle .java. I'm gonna use upper camel case. I think that's a Google standard. Okay. Cool. So area of a circle.java. The goal of this is to take one input and output the result. So let me set up the boilerplate. Okay, so void main. This is the boilerplate. This will make sense later. This is an entry point to the Java program. The first thing we see is we should prompt the user for a number. This means tell the user to type something. For this first line of code, you see it says, oh, type a radius. So if you wanted to follow this exactly, you could output that. You could put it on this side. You could do something like, oh, type a radius. So I'll do a print line and then type a radius and then colon space. Okay, and then this 5 does represent input. It's not part of the output. So we saw earlier that we can use the io.readLine. io.readLine. This is a function that waits for the user to type something. But this function does return a value. So it would be useful to store this value into a variable. This way we can use the variable to perform future calculations. So for now, I'm going to store this in an integer. This is the wrong data type, by the way. Hopefully people see what we should store it as. But I'm going to store integer radius is equal to here. And we'll talk about something in a bit. So yeah, we create an integer called radius, and we're going to store the whatever's input. Let me test it. So Java area of a circle. By the way, you can press tab for an autocomplete. So Java area of a circle. Okay, check this out. So we got an error here. The error is pointing at line 3 right here, and it says incompatible types. So this is a compiler error. The compiler is telling us that both sides don't match. The right side, this is a method that returns a string. So if you're curious what that means, it just means that when this method terminates, it'll collapse to a string. It's gonna collapse to like whatever we typed in. If we typed in 5, it's gonna evaluate to 5 over here. This is a syntax error because a string cannot be converted to an integer. The designers of this function method, I mean, let me just pull up some documentation here. If you were to look at the IO library, I have the IO library somewhere. IO methods right here. So if you were to look at the documentation a bit, there's a method here called readLine. This is the primary documentation, by the way, oracle.com. This is a method that returns a string, meaning it's going to treat it as a text. So yeah, both sides don't match. One way we can mitigate this is by converting this right side to an integer, because the right side is evaluated first. So one way we can convert this right side to an integer is with another function, another method. I mean, there's a method from the integer library. If you were to look up integer class in Java, if you were to look up the integer class, this documentation is kind of hard to read right now, but the takeaway here is there is a method called parseInt. ParseInt is a method that converts a string into an integer. So we could use this by treating this value as an input to this function here. So the function, method, parseInt is going to have some parentheses, and the string will go inside of those parentheses. So one way we could do that is by saying integer.parseInt, and then wrap this whole thing wrap this whole string into this method called parseInt. So yeah, if you're curious how that came about, where is it at again? ParseInt. Let me search. ParseInt. I'm using this method over here. So parseInt comes from the integer class, and it takes something called an argument. An argument is an input to a method. So in this case, the input I'm using, string, is over here. People see what's happening here. The string is right here. ParseInt is right here, and then it comes from the class integer right here. So yeah, this is converting. This is it's doing a lot of things actually. This is first thing it does is it reads a line of text, because that's order of operations inside of these inner parentheses. We read a line of text and then convert it to an integer. So that's this over here. We're parsing an integer, so converting, and then finally we're assigning it to this variable called radius. So reads a line of text, converts it to an integer, and then stores it to a integer variable called radius. Okay, so yeah, there's a lot of things happening in this line. Let me test this real quick. So let me go up and then run it. Okay, cool. So we have a output. It says type of radius. So now the program is waiting for input here. So I'm gonna type in something like 5. Okay, the second I press enter, this method will terminate. It's going to collapse to a 5. So if you're curious what's happening, this is going to evaluate to 5 like this as a string. And then 5 gets converted to an integer type, so we can properly store it here. So let me go ahead and press enter. And yeah, the program finished. There's no further output because we never did any more output. But yeah, hopefully people see what's happening here. Let me go ahead and split this line into multiple lines because there is quite a bit happening in here. Another way you can represent this same exact line is by first reading the line. So let me comment this out. So this, let me read the line. Okay, this does store a string. So you could store it into a variable called user input. So this is like saying, hey, type something. When we press enter, user input will become that text, and then we can go ahead and convert it. So we could convert it by using the integer.parseInt and then put in the user input here. Okay, so yeah, once again, this method converts the string to an integer. This method does return an integer, meaning we should store it into a variable. We need to store it into a variable so we could use it in a future calculation. So I'll store it in a variable called radius again. And let me just test this real quick. So Java, area of a circle, type radius, 5, enter. Okay, cool. The program behavior is the same. Yeah, these two lines is the same as this line right here. So I just split it up so it's a little easier to read. Okay, let me comment this. Same thing as above. Okay, I'm gonna go ahead and fix the output real quick because we see in the goal of this class exercise, we expect the output, it might seem picky, but we expect the output to have the user type in the number to the right of the colon. It is such a small nitpick, but you'll see in future classes that behavior need to be exactly as expected. So if you wanted to make this exact behavior, you see how if we type in a 5, it's not on the same line. The reason why is because this first print statement automatically adds a new line in the end. When we use this print statement, print line, this is the same as saying print, but then it's going to put a new line here. We covered this last week. This is an escape character for a new line. So yeah, these two lines are the same here. Let me comment it. All right, these two lines are the same. Okay, so if we were to just use the print statement without the line, then we should be able to type to the right of it. So let me rerun this program. So Java, area of a circle, and there we go. So it says type of radius, and the user input is to the right of it. We can type 5, enter, and then the program finishes. Okay, there is something going on in program though. We are storing 5 into the memory, and it would be useful to use this variable to calculate the area. So let's go ahead and use that variable to get this. The area is equal to pi r squared. So one way you can represent this is by storing it in an integer. This is incorrect, by the way, using integer. I'll change it in just a bit. So if I were to store like the area of a circle, so I'm declaring a variable telling the computer, hey, I need memory for an integer. And I'm going to initialize that memory location to the result, which is pi r squared. Okay, for now I'm going to hard code pi, meaning I'm just going to have pi live in here. So this is pi r squared, and then r squared. One way you can do this is by getting the radius times the radius. There's multiple ways you can do this over here. But yeah, I'm calculating the area of a circle, and then I'm just going to go ahead and print it out, because the final line of output is the area of a circle is something. Okay, so let me go and print that out. The area of the circle is, and then let me concatenate the result. So area of circle. There we go. Okay, let me go ahead and test this real quick. So Java. Okay, and I got an error message here. This is expected. The compiler is telling us something about incompatible types, where we're mismatching types. The pi here is represented as the double, and then the radius is being represented as an integer. So the compiler is telling us there's a possible lossy conversion here. It's pretty much telling us that we're going to lose some precision. So yeah, the compiler is protecting us from a possible truncation. You saw earlier that with integers, the decimals will be truncated. So it would be more appropriate to use a double instead. All right, because there is possible test cases where we do type in doubles, and we don't want the decimals to be ignored. So I'm gonna go ahead and convert this to a double real quick. So this is line number 9. We need to store this as a double, and then there is a method that's pretty much the same thing. Double.parseDouble, I believe. Let me look at the documentation. Oh, let's see. Someone in Zoom chat says, "Can I use 5.0 as an input?" Yeah, you can use 5.0 as an input, but this line is still going to print out the truncation. Here, let me back up a bit. So if I were to echo out this radius, so io.print line, the radius is, and then let me radius here. Okay, cool. So I'm just gonna echo this. So Java, if I type in like 5 here, 5 and then enter, the radius is 5. Makes sense. If I do something else like 5.9 and then enter, I got a an error message. So yeah, sometimes it will work depending on your implementation, but in this case it doesn't work because we got a runtime error. The runtime error happens during execution. So this is not a compiler error. See, so I'm running it. It does compile, so we're inside of it. But if I type in like 5.0 and then enter, I get a runtime error. It failed over in line number 9. So this is a stack trace, or it's a trace through where things might be going wrong. In this case, line number 9 right here, we get an error because 5.0 can't be converted to a radius. So yeah, there's a couple ways you can mitigate this, but for now I'm gonna keep it simple and just use a double instead. So I'm gonna use a double radius, and then since we're converting the right side to a double, the methods would be double.parseDouble. I'm totally guessing here because the integer is probably the same way, but you could verify this by looking up the double library. So let me see if this does exist. Let me look up the double library. So double class Java. And then let me look at the primary documentation here. Okay, I'm gonna look for a method called parse double to see if it exists. Okay, yeah, there is a method called parse double, and it takes a string. So yeah, this is the method I'm using over here. Okay, and then let me just echo it out real quick to make sure it's good. Echo means just to print back out so we could verify. This is a sanity check. Radius is, and then let me put the radius here. Once again, this is a sanity check. It's a good idea to test your program frequently and verify the variables before you move on. Because if you make a mistake early on, it's going to be kind of hard to catch if you implement way more features. So you want to sanity check things along the way. Okay, so Java area of a circle, and then whoops, I made a typo here. I typed in some Java area of a circle. I'm just gonna tab for autocomplete. Type of radius, I'll say like 5.9, and hopefully there's no runtime errors. Press enter, and okay, radius is 5.9. Perfect. So we sanity checked it. Maybe you could sanity check more, like 10.5, and cool. No more runtime error. Okay, so we sanity checked our radius. Now we can finally go ahead and create the area of a circle. So I'm gonna represent this as a double because we can have decimals. Okay, there we go. Let me zoom out a bit so people can read this. Okay, can people read this? Yeah. Cool, I'm gonna save this. Rerun. Okay, type of radius, I'll type in like 5, enter. Radius is 5. Okay, I forgot to save it. So that's why I didn't print out this area of a circle. It's giving me the old source code. So let me save it again, my bad. Control. Okay, save. And let me rerun it. Type of radius, I'll say 5, enter. And then cool, the area of a circle is 78.5 something. Let me see if that's right. Okay, yeah, that looks about right. The area of a circle is 78.54. Cool. Yeah, so that's pretty much the class exercise. We could test out with more here. Like there's another test case. Test cases verify if your program is working correctly. So let's test it with 2.4. Okay, let me rerun the program, enter, and I'll draw 2.4, enter, and then now we get this 18 point, yeah, this looks about right. If anything, it's gonna be more appropriate to format it to 2 decimal places. One reason is just because the problem asked for it. And then another reason is because some people really don't care about the smaller precision. So most people care only about 2 decimal places, especially with money. So if we wanted to modify this output to and format it to 2 decimal places, well, there's tons of ways you can do it. But one way you'll see is is with this method called print format. So far, we're using this library called IO, and we're able to use some print statement like print line. However, these methods don't have a lot of power. For example, it doesn't really have the power to format. It doesn't really have the power to format a string inside of it. So one way you can do this is by using the system.printf. Here's what I'm gonna point out right here. Let me look for it. So let me see, printf. Okay, I'm gonna end up using this function called printf, which stands for print format. This is a function, you'll see this in the reading, I think. But there's a function that comes from the system.out.print. So if you take a look at the reading, you'll probably see a lot of system.out. System.out is the same. I mean, not the same. The IO library does some stuff from system.out. But another way you can represent this is with print line, and then putting this in here. So just real quick, both of these do the same. This first one, this first line, is a newer style. This second one, I wouldn't really consider it an older style, but it's more of a standard style that has a lot of flexibility. So yeah, just real quick, these two lines do the same, and just to prove it, I'll rerun the program, type in 5.0, and then yeah, we get two of the same exact print statements. So these two are the same. The only difference is since we're using the system.out object, it comes with a method that IO doesn't have. It's called a printf. So I'm gonna use this function over here, printf, and explain what it does. Okay, so the way printf works is it takes a certain amount of arguments, inputs. I mean, the documentation is a little hard to read right now, but we see that the first type of input is some sort of string, and then the second input is some sort of arguments. So here, let's explain what this means. So the first one is a string, and then the second one is something. The string here, this is called a formatting string. So if I were to print out, the area of the circle is, and then a let me see. What should I do here? I don't want to go too far ahead. You know what? Let's just introduce something called a formatter. So there's this mini language that allows you to format certain things. If you were to use this percentage sign, this percentage sign is a formatter, and anything ahead of it will be substituted by something. It just happens that if we use a 0.2f here, 0.2f, this is saying I want to round 2 decimal places and treat the number like a float. A float, once again, is like a double. It's just a fancy word of saying decimal. And then the second argument, so I put a comma here, and then the second argument, if I were to put a area of circle, let me explain what's happening here. So I'm using this method here. Okay, the first argument here is a string format. So that's right here, that this is a formatting string. And there's a little piece here. You could look this up. I'll refer to this later, but this is like a mini language. This percentage.2f will format it to 2 decimal places. It's going to be substituted by this next argument here. This next argument is some sort of object that will substitute into here. So let me go ahead and run this. So Java area of a circle, and then I'll go 5.0, enter, and people see what's happening here. This second statement is rounding or it's formatting to 2 decimal places. So yeah, that's one way we could format by using this printf. This is a very common thing in a lot of languages. Printf exists in C, it exists in Python, and in Python they call them f strings. But yeah, this little mini language exists in a lot of programming languages. Let me look it up real quick. I forgot what it's called. I think they're called like string formatters. Let me look it up. Yeah, so you could look this stuff up. It's kind of a rabbit hole. You could look up string formatters in Java. It does apply in a lot of other languages though. And if you want to take a look through some of these, it is a little hard to read right now, but there's a bunch of examples and they'll explain what the percentage is doing. The percentage sign is specifying that the future will have some sort of formatting. And we use something called point2f. F stands for floating point, and it's going to substitute the number as a decimal. So yeah, there's tons of formatters. Okay. People cool with this so far? Let me rerun the program. So 5, enter, 78.54 looks good. Let me compare it to the answers over here. So 5 and 78.54, that looks good. Let me try it with this one over here, this second test case, 2.4. So Java area 2.4, enter, and we get 18.10. Let's verify. 18.10 looks good. Great. Okay, people cool with this small exercise so far? This is probably what the next programming project is gonna look like. I haven't published it yet, but it's gonna look something like this. Take in some inputs and calculate something from it. Okay, any questions about this so far? Okay, cool, let's move on then. I did mention earlier that there's something called a final. This is like a constant. So constants are numbers that aren't supposed to really change. Otherwise, it could be considered insecure. For example, pi. I did hard code pi here as 3.14. Hard coding means the data lives in source code. But you know, one way you could also represent this is by storing the variable beforehand. So I'm going to create a variable called pi, and then set it equal to 3.14159, semicolon, substitute this here. It's actually more appropriate to grab pi from a library. I forget which library it comes from. I think the math library. But you don't have to hard code this. You can probably do something like math.py or something. I forget the exact name of it, but I'm just gonna do this temporarily. So you could store pi as here, but there is kind of a security hazard. As programs get bigger and bigger, the structure of the program can consist of multiple files. Currently, this program consists of just one file, area of a circle. But yeah, bigger programs, you're going to be putting multiple files together. Imagine you're working at a company and there's a bunch of coworkers. Certain coworkers might be working on different files. You might be working on a certain file, but then in the end, things should kind of come together. So if you were to imagine multiple files, there's a possible security hazard where a coworker or someone else can change pi. Like let's say your coworker in another file says, "Oh, pi is now equal to 3 for some reason." So this is kind of a possible security hazard, because if it's changing the result, and we're going to end up with a logical error A logical error means the program did run, but we have this incorrect result. So this does work. 5, it does work, but we have incorrect result because the precision is lost. We lost the decimals. Okay, so this line right here on line 12, you can imagine this as someone changed a variable that shouldn't be allowed. Okay, someone changed a variable. I changed it, but you can imagine as your coworker made a mistake. This is a possible security hazard. And one way you can mitigate this is by treating pi as a constant. So in Java, we can treat things like a constant by prefixing the type with final. So I just prefixed this variable with final, meaning this number is not supposed to change. So let's go ahead and test this real quick. So Java, area of a circle. We got an error message. This is actually a good error message. It's pointing at line 12, and the compiler is saying cannot assign a value to final variable pi. This is pretty much telling us pi is meant to be read only instead of write. Read and write. That this is meant for reading. So line 12 is attempting to write pi, but that shouldn't happen. Pi is read only. So let me get rid of this security hazard. And then it should be fine now. And yeah, 5 works. So yeah, people see what's happening here. By making things constant or final, it's preventing other pieces of the code from modifying things that shouldn't happen. So if your coworker or if another person were to change pi, they're going to end up getting an error message, which is good. The error message is protecting from bad behavior. Okay, people cool with that so far? So that's kind of like a final. There's something called magic numbers as well. We'll talk about this next week. Okay, any questions so far about this? Okay, cool. So yeah, we just covered a class exercise. Once again, these are good exercises for the exam or the future programming projects. In the future, I highly recommend pausing the video and attempting it yourself before seeing the solution. The biggest reason is so you can gain some meta skills like problem solving, creative exploration, troubleshooting, and all of that. There's an infinite amount of ways you can represent this solution. So I highly recommend it trying out yourself. If you copy it from somewhere, it's probably going to ruin creativity, but you can also learn from that too. I would just do things a little responsibly and try to understand every step along the way. Okay, so yeah, we just covered a class exercise. I want to mention a few more things and we'll be done for today. By now, we have probably encountered most of these types of errors. We've seen syntax errors. These are like grammatical errors that the compiler will catch. For example, if I were to like miss a semicolon here, I'm just gonna remove this semicolon right here. So I just remove this. It's gonna give me a syntax error, meaning a compiler error. So the compiler is kind of doing some grammatical checking. It's checking to see if things are typed correctly. In this case, it's not. So it failed compilation and we're not able to run the program. So that's an example of a syntax error. There's tons of them. There's also runtime exceptions. These are errors that happen during the program's execution. For example, if I were to run the program again, Java area of a circle, Here we go. So it did run, no syntax errors. Let's go ahead and invoke a runtime exception. Our program is currently stuck right here. Okay. If I were to type in like hello, if I were to type in hello, line 8 would complete successfully because hello is a string that can be stored in here. But then we're probably going to get an error here because hello is user input. So what happens if we convert hello into a double? Well, let's see. I'll press enter. And we got an exception. It's pointing at line 9. Specifically, it's saying, hey, the method cannot convert the string to a double. This makes sense because hello is not possible to convert to a number. So we got an exception, which happens during the execution of the program. There are ways on protecting this. We'll have to talk about it next week, though. Next week we'll talk about if statements, and we'll be able to do something called bounds checking and validate whether or not the input was typed in correctly. So yeah, there's some runtime exceptions, and then finally there's logical errors too. Logical errors mean the program did run, but there can be possible bad behavior. Like an example of a logical error is if I made a miscalculation here. Like let's say I forgot to square the radius. So this, I'm just going to remove that other radius. The program still works. You type in 5 and then enter. But now the area of a circle is an incorrect result. So yeah, this is a logical error. A logical error happens when everything is working fine, but things in your code can represent the wrong values. So this is why it's a good idea to test your program incrementally. For this intro class, maybe every couple lines you want to test. You know what I mean by testing? Like sanity checking the values of each variable before you use them. Okay, so yeah, those are some error messages. All right, so that's it for today. On Wednesday, we're going to finish all of this stuff. On Wednesday, we're going to do some additional topics on string manipulation. Today, all we did was use numbers. We just use integers, doubles. We haven't really done much with strings yet. But strings are good for analyzing text. A string is, once again, this is like a way of representing a bunch of characters, like all the alphabets. So we'll talk about this next week. There's going to be a bunch of optional things. I mean, not optional, some additional things. We'll talk more on strings. We'll talk about something called a J shell. This is a useful tool which will help us in the class. And then we'll also do a bunch of more things on input. So yeah, let's save this for Wednesday. But for now, let's just summarize what we did. So we did these 3 sections here: 1.3, 1.4, and 1.5. These are using input output with numbers. Highly recommend doing the reading. I think I covered most of the stuff, but there might be some small gaps in between. So yeah, please look through these supplemental material. It's a good use of lab time. Okay, that's about it for today. I think Wednesday is going to be pretty chill because we just have to finish these things. Okay, and then I'll have the next assignment published in a day or two. Okay, thank you all, and have a great day, folks.